Find the partial fraction decomposition of the rational expression. So let's take a look at this rational expression. Now this is going to kind of bring back bad memories for you guys probably. Because what that means is everything we've had prior to this, the bottom was factored. Now this one, the bottom isn't factored. So what does that mean for us? That means we have to factor x cubed minus 4x squared plus 5x minus 2. Now how do we do that? Do you guys remember that zero remainder theorem? That means I look for the P over Q. Okay, that's what we'd have to go through to find this out. And I found 1, 0 right away as soon as I started the process. I plugged in 1, and 1 is actually a 0 for this. So if I plug in 1 into the bottom, I'm going to get 0. So that tells me x minus 1 is a factor. And then what am I going to have to do with that? I'm going to divide it, right? Or I can use synthetic division, okay? Whatever you have to do there to get the answer for that. Now on a test, you'll have to show that step in there. So I have to give you a lot of room for these problems. Totally understand that. And it's, again, a little headache, but go back to it. And then it's going to factor into x squared minus 3x plus 2. Now again, we're still not there yet because this here can also be factored. It's a trinomial and it can be factored. So this turns out to be x minus 1, and here what factors give me 2? And it's negative 2 and negative 1. So this is going to be x minus 2, x minus 1. So we end up with a similar problem that we had to the previous one. So we really have x minus 1 squared times x minus 2. So that's what we're going to have to put in here. So then we get for the first one the x minus 2. And then for the second one, we're going to get an x minus 1. And then for the third one, we're going to get an x minus 1 squared. Because keep in mind here, this is really x minus 2 times x minus 1 squared. So that's why we have to get the set up this way. Now again, they're all degree 1 on the bottom except for the last one. But again, since that's a multiple factor, that's still going to be degree 1 on the bottom. So we're going to end up with an A, and then a B here, and then a C here. So now from there, we just do what we normally do. So for us, that means I look at this first one here, and what do I got to multiply that by? Because remember, we're going to add all these together. So then this one right here is going to need a x squared, or x minus 1 squared. So that means I have to multiply the top by x squared, x1 minus squared. And the middle one has an x minus 1. So it's going to need an x minus 2 and an x minus 1. So then the top is going to need an x minus 2, x minus 1. Now the third one already has an x minus 1 squared, so all that one needs is an x minus 2. So the top needs an x minus 2. So now what we're going to do is we're just going to multiply this all out and create our new tops for these. And again, just like I said in the last one, remember, this here is a FOIL. That's an x minus 1 times an x minus 1. So that's going to result in. So this is what we end up with when we multiply it all out. And times them all by A, B, and C. Okay, so there it is. So now from here, we're just going to do our setup now. Just kind of like I always do. Now remember, we're adding all these together, and it's all the tops. So that means I'm going to get ax squared minus 2ax plus a, and the middle is going to be bx squared minus 3a, or 3, sorry, bx plus 2b, stuck on a there, 2b, and then c is going to be cx minus 2c. There it is. So there's my 3 now. So now I'm going to go through setting up my equations. So this is ax squared plus bx squared. Now over here, notice this, there's a 1 in front of that one. I don't see anything. So I have an x squared up there. So that tells me then a plus b is going to equal 1. And then the negative 2a plus, minus 3b plus c equals 0 because there's no x's up here. Just an x squared. And then my numbers on the end, which are my constants, and again, I don't have any constants up here, like plus x, plus 2, or anything like that. So that's why the first one's 0. And then the second one's 0 for the same reason. So that's going to be a plus 2b minus 2c equals 0. So there's our three equations again. Now, again, just like I did the other one, if you didn't watch that one, I can, in essence, I can't for this one. I was going to say solve for a or b. Now I can do that and then plug it in the other two. Actually, I still can do that. Or I can use reduced row echelon form on a matrix. But yeah, I'll do it that way still. I can still call this, it's not as nice, but we can still do it, that a is going to equal 1 minus b. And then in essence, what we're going to do is we're going to take this 1 minus b and plug it in for a into the other two equations. So yeah, I guess we could do that. It doesn't change. Okay, so now that's what I'm going to do next. And I'm just going to show you all the work there. And if you need to pause it, you can, just for the sake of the length of the video. So here we are. So again, for this first one here, that's up here. Okay, and then for the second one, that one starts here, where I subbed into 1 minus b there. And what we end up with is this equation here and this equation here. So one thing to be careful of in that top equation is, remember, when you distribute the negative through, make sure you get the negative on both of them, because you end up with the positive there. And from that, there's one more idea I want to express here, that when I get down to this step here, remember, I got to move the 2 over to the other side because I have to have my letters on one side, numbers on the other. So that's the idea there. So those are the two things to kind of keep in mind. Now with those two equations, now I have two equations and two unknowns. So now from there, I can use another method if I want to. So negative b plus c equals 2, and the other equation is b minus 2c equals negative 1. Now I'm going to use the elimination method here, and the reason why is because I noticed right away that I already have my b's as opposites. So if I add those together, it's going to make it a lot faster than trying to do a substitution method here. So then when I add my c's together, my b's go away because they're opposites. And then for my c's, I get a negative c equals 1. So then c equals negative 1. So there it is. I get it right away, really quick, which I like. I like when that happens that way. So now I'm going to go and back substitute and try to find out b now. And I'm going to actually use this one here, since that's the simplest looking one there. Seems like it'll be the easiest. So then that tells me negative b and I'm just going to put minus 1 there equals 2 because I'm subbing it into this equation here. Okay, and then when I move that 1 over, I'm going to get 1. So negative b equals 1. So then b equals negative 1. All right, so I get those to be both negative 1. And then I'm going to go back to one of my originals, possibly, and find out which one I can use. Oh, and I see this one here. That's going to be a nice one to use there. Because if I know b is negative 1, I'm going to actually use that red one there. Because then a is going to equal 1 minus a negative 1, which actually equals 2. So a equals negative 2. That's my third one. Now we're ready to plug everything in and be done with this problem. So then if we go back to our original here, this is going to equal Now for my a is -2, so I'm going to put a -2 here. And then on the bottom, I'm just going to have the x minus 2. And then for the middle one, both b and c are -1, so I can just take those away and put minuses in. And then for the second one, I'm going to have x minus 1, and that's going to be a 1. And then the last one's going to be an x minus 1 squared. And then that's going to be a 1 there. So there's our answer for this one here. I thought I was done with this one, and I looked at it and something seemed off to me, and it was. Where I messed up at was right here, right at the very end. And what I did was, just doing some of this simple math in my head really screws things up. So I need to add 1 to both sides. And in adding 1, I don't get 1. I actually get a 3 there. So that should be a 3. And then my b then shouldn't be -1. My b should equal -3. So when I looked at it, I'm like, that just doesn't seem right. So my b is actually -3, which is also going to change my a. Now I'm still going to use the same one. I'm still going to use this equation, and I apologize for that. But now my a, and I'm going to use that red one still, is going to be 1 minus a -3. So that a then is going to be 4. So my a doesn't equal that -1 like I thought, but my a equals 4. So now I'm going to have to plug all those in and fix those. Now it doesn't change a lot here. Well, it changes the numbers, of course. Oops. That number was okay. So that's going to stay a 1 there. That's my c. But then these numbers here are going to change. And the signs may too. So I'm just going to take those out of there. And then my a is 4. So I'm just going to put my 4 in there. And then my b is -3, so I can keep that minus sign there. So there, that is actually truly the answer here. And again, I apologize for that error, and I'm glad it was in the end, so I didn't have to redo it. I have to be careful here when I move stuff over. Sometimes I drop a sign here and there, and we're all susceptible to that. But there's our final answer now.